Hello everyone, welcome to the session of class 9 mathematics, and I am your Anu for mathschool.1. Last class we have been seeing some problems in polynomials, and I have stopped up to the some regarding remainder theorem, and I have said you how do we get remainder. Using the remainder theorem, we substitute the value of x, that is the root of the polynomial, or the value of x in the polynomial, and if we get a value for some value as a result, we say that it is a remainder, or if we get 0, then it is understood that the given value of x is the root of the polynomial, isn't it? So let us continue with some more problems so that we could understand more better, still better. Okay, now let's move on to the problems. Now the next problem is determine the value for a. Again it is given. See, the polynomial is 2x power 4 minus ax cube plus 4x square plus 2x plus 1, and it is divided by 1 minus 2x. Okay, now the question is determine the value of a for which the polynomial, given polynomial, is divisible by 1 minus 2x. Now they have said that it is divisible by 1 minus 2x. So what does it mean? If you say a linear polynomial or some polynomial is divisible by divides the polynomial, or the given polynomial is divisible by the linear polynomial, it means that the given polynomial 1 minus 2x is a perfect factor of the polynomial. Okay, do you understand? So what is the condition for a linear polynomial to exactly divide a given polynomial is when you substitute the value of x of the divisor. We get the value of x from the divisor, from the linear polynomial, when you substitute to 0. So whenever we need x, we need to substitute the polynomial to 0. We equate it to 0 and we get the value of x, and that value of x is substituted in the given polynomial, and we see if the answer is 0, if the result is 0, then we say it is exactly divisible by the divisor. Okay, now it is already given it is divisible. Now we need to find the value of x, that is 1 minus 2x, we equate it to 0. Okay, so from this minus 2x is equal to minus 1, or x is equal to 1 by 2. So x is equal to 1 by 2 is the root of the equation, since it is divisible by the linear polynomial 1 minus 2x. So now substitute, if this is taken as f of x, I need to substitute 1 by 2 in x, that is f of 1 by 2 is equal to 2 into 1 by 2 the whole power 4 minus a into 1 by 2 the whole cube. Now we need the value of a, and it is given it is perfectly divisible by the linear polynomial. So I need to substitute 4 into 1 by 2 the whole square plus 2 into 1 by 2 plus 1. So 1 by 2 is substituted in the value of, in the place of x. So 2 into 1 by 16 minus a into 1 by 8 plus 4 into 1 by 4 plus 2 into 1 by 2 plus 1. Now let's cancel 8, 4 get cancelled, 2 get cancelled, and we get 1 by 8 minus a by 8 plus 1 plus 1 plus 1. Okay, you understand this? Now this is equated to 0 because x minus 1 minus 2x is exactly perfect factor of this polynomial. Therefore f of 1 by 2 is equal to 0. Now we will write it here. F of 1 by 2 is 0. That is given because it is given that it is divisible. Okay, so now what I need to do is minus a by 8, let it be in here, and I take the rest of the things to the right side. 1 plus 1 plus 1 is 3. So when I take to that side, it becomes minus 3, and plus 1 by 8 becomes minus 1 by 8. Okay, now I do this here. See, minus a by 8 is equal to, what is minus? You need to find the LCM. So 8 is the LCM. Minus 24 minus 1 divided by 8, that is equal to minus 25 by 8. Now I bring the 8 to this side. Minus a is equal to minus 25 by 8 into 8. See, 8 gets cancelled and you have a is equal to 25. So we have found the value of a. A is equal to 25. So whatever given in the problem, you have a hint from it, you have a clue from it, and when you substitute the value of x from the linear polynomial given, that is 1 minus 2x, isn't it? This is a linear polynomial which divides the biquadratic polynomial which is given. So you substitute this to 0, you equate it to 0 and have the value of x, that is x is equal to half, and put the half in the biquadratic polynomial given polynomial and equate it to 0. Therefore you get a value of a as 25. Now do you understand? Now what we are doing, the sums are, all the sums we have done so far follows the remainder theorem. Okay. Now the next problem is, now ax cube given, given a polynomial ax cube plus bx square plus x minus 6 has x plus 2 as a factor. So this is a factor, okay. That is, if it is a factor, it exactly divides the polynomial. So what did I say? You get x from it, x is equal to minus 2. That is, x plus 2 is equal to 0. Equate it to 0, you get x is equal to minus 2. So x is equal to minus 2 you have. So when I substitute in the equation, what should I get? I should get 0, isn't it? So I should equate it to 0. Since there are unknown values here, a and b, I won't be getting 0. I need to find a and b so that it becomes 0. So x is equal to minus 2 is root of the equation. And the next point they have given is, and leaves a remainder 4. See, it leaves a remainder 4 when it is divided by, x minus 2. Okay, when it is divided by x plus 2, it leaves a remainder 0. That it is a factor. X plus 2 is a factor, means it leaves a remainder 0. When it is divided by x minus 2, it leaves a remainder 4. Okay, so from this we get x is equal to 2. Now let us write it short. See, f of minus 2. When x is equal to minus 2, you have 0 as the value. When you substitute minus 2 here, it should be equated to 0 because x plus 2 is a, which implies x plus 2 is a factor. And when I substitute 2 here, I get a remainder 4. It implies that x minus 2 divides and leaves a remainder 4. That is, it divides, it doesn't divide perfectly. So it divides and it leaves a remainder 4. Do you understand? So this is how we proceed with the given statements. So I need to find f of minus 2 and I need to find f of 2, equate it to 0 and 4 respectively, and find the values of a and b. Now whenever you are given with two unknowns, if one unknown is given, as in the previous problem, one unknown was given, that is a was given, just the a unknown was given, and you were given with only one condition, that is the linear polynomial divides the biquadratic polynomial exactly. So the one condition is enough for you to find the one unknown. But here, since there are two unknowns in the equation, you should have at least two conditions to solve it. That is, you should have two conditions like this to solve the given two unknowns, to find the value of two unknowns. Okay, now let us proceed with the problem. So f of minus 2 should be equated to 0 and f of 2 should be equated to 4. So f of minus 2 is equal to a into minus 2 the whole cube plus b into minus 2 the whole square plus minus 2 minus 6, and this should be equated to 0, isn't it? Now this is equal to, I am doing it directly, minus 2 cube is minus 8. So minus 8a, minus to the whole squared is 4. So plus 4b, minus 2 minus 6 becomes minus 8, and that should be equated to 0. Now minus 8a plus 4b is equal to, bring this minus 8 to this side, this becomes 8. Now I cancel throughout, now I divide throughout by 4 because 4 is the common factor for all the three numbers. So I get minus 2a plus b is equal to 2. So this is my first equation. Take it as your first equation. Now the second condition is f of 2 is equal to a into 2 cube plus b into 2 squared plus 2 minus 6. Now this should be equated to 4 because it leaves a remainder 4 when it is divided by x minus 2. Now this gives 8a plus 4b, 2 minus 6 is minus 4 is equal to 4. Now 8a plus 4b is equal to, bring 4 to the side, it becomes 8. Now I'll divide throughout by 4. So 2a plus b is equal to 2. Now this is my second equation. Okay, now I need to solve both the equations 1 and 2 to get the value of a and b. Now let me do it here. So I'll take down the equations. 2a plus b is equal to 2 is my first equation. 2a plus b is equal to 2 is my second equation. Okay, I need to solve them. Then I'll be getting the value for a and b. Now see, readily this equation is minus, this 2a is minus and this is plus. So I can add both the equations so that one variable gets cancelled. B plus b is 2b, 2 plus 2 is 4. So b is equal to 4 by 2, that is 2. So b is equal to 2. I got one of the answers. And substitute this b in any of the equation. I substitute in 2. So 2a plus 2 is equal to 2, or 2a is equal to, okay, 2a is equal to 2 minus 2, which is equal to 0, or a is equal to 0. You understand? So substitute here, a plus b is 2, so is equal to 2, so it is correct. So this is what, a is equal to 0 and b is equal to 2 are the answers for the given biquadratic polynomial. The unknowns are known now. Okay, do you understand how do we proceed with the sum? As we have two conditions, we use the two conditions to to determine the equations, and then solving the equations will give you the two unknowns. Okay, just you need to see whether the remainder is 0. If it is, the remainder is 0, you need to substitute the value of x and equate it to 0, and if it leaves a remainder, you substitute the value of x and equate it to the reminder's value. Okay, now the next one is C. If f of x, here again f of x is equal to x power 4 minus 2x cube plus 3x squared minus ax plus b. Another sum of this type is a polynomial such that when it is divided by x minus 1 and x plus 1. Okay, listen carefully. It is divided by x minus 1 and x plus 1. It leaves remainder 5 and 19. So for x minus 1, I have x is equal to 1. So what is f of 1? It leaves a remainder 5. Okay. Then when it is divided by x plus 1, that is for f of minus 1, it leaves a remainder 19. Now you have, as I said, you have two conditions to solve values of a and b. With this, what you need to do is determine the remainder when f of x is divided by x minus 2. So now what they are asking is, after you find a and b, substitute the values of a and b in the given polynomial. You will get a full polynomial with all values known. And now what you need to do is, you should find the remainder when that f of x is divided by x minus 2. So what do? We substitute the value of x where x is equal to 2, and we get the remainder when the polynomial is divided by x minus 2. Okay, so now we'll proceed with the problem. F of 1 is equal to 5 and f of 1 is equal to 5 and f of minus 1 is equal to 19. Now I substitute f of 1. I do it directly because it is 1. This is equal to 1 minus 2 plus 3 minus a plus b is equal to 5. Now 3 plus 1 is 4, 4 minus 2 is 2. So minus a plus b plus 2 is equal to 5, or minus a plus b is equal to 3. Now this is my first equation. Okay, now f of minus 1. I need to determine f of minus 1. So minus 1 the whole power of 4 is 1 minus 2 into x cube, that is minus 1 the whole cube is minus 1. So minus 1 into, so I'll do it more clearly, minus 1 plus 3 into minus 1 squared is plus 1, so 3 minus a into minus 1 plus b, and this will be equal to 19. Okay, now let us solve. Minus 2 into minus 1 is plus 2 plus 3 plus a plus b is equal to 19. Now a plus b is equal to 19 minus, this is 6, so 19 minus 6 is 13. So a plus b is equal to 13 is my second equation. Now do you understand how do we get both the equations from the given conditions? So minus a plus b, I write it here, minus a plus b is equal to 3 and a plus b is equal to 13. Now we'll solve the two equations to get the value of a and b. Minus a plus b is equal to 3 and a plus b is equal to 13 is my second equation. Now see, directly I can add both the equations. So 1 plus 2 will give me 2b, this gets cancelled and this is equal to 16, or b is equal to 8. Now I have the value of 8 here, and now for the value of b I take the second equation. For value of a, now a plus 8 is equal to 13, or a is equal to 13 minus 5, that is 5. 13 minus 8, sorry, that is 5. Now we have got the value of a and b respectively. Now what you need to do is, if we have got the polynomial. See, we have got the polynomial. I am putting the value of a and b in their respective places. 2x cube plus 3x squared minus ax, that is minus 5x plus b, that is 8. Okay, now the equation, the polynomial is complete now without any unknowns. Now what we need to do is, we should find the remainder when this polynomial is divided by x minus 2. Now what do? We equate it to 0, we get x is equal to 2, and we find the value of f of 2 to find the remainder. So that is the remainder theorem, isn't it? So x 2 power 4 minus 2 into 2 cube plus 3 into 2 squared minus 5 into 2 plus 8. Now what do we get? 2 power 4 is 16 minus 2 into 8 is 16 plus 3 into 4 is 12 minus 10 plus 8. Now 16 gets cancelled, and 12 minus 2 is 2, 12 minus 10 is 2, 2 plus 8 is 10. So what is the remainder when it is divided by x minus 2, when the biquadratic polynomial is divided by x minus 2 linear polynomial? We get a remainder of 10. See, f of 2 is 10 now. Now I think you would have got an idea, you could have understood what is remainder theorem properly, isn't it? So we have done more problems than enough. So you will be able to understand the remainder theorem more clearly now. Isn't it? So these were the problems. Some of the problems we have done with remainder theorem, and we still have some more problems based on factor theorem, and still we have some problems in remainder theorem too. So that we'll be seeing in the next class. So until then, it's bye from Anu for Maths Core.1. Thank you.